Meeting room. Good afternoon, everybody. Thanks so much for being here with us for today's roundtable focused on heat pump water heaters. Again, if you haven't had a chance to drop a short introduction in the chat, we'd love to know where you're from and what kind of role you've got. And of course, this training is meant to be interactive, so please do feel free to ask questions as we go along, either in the chat or you can feel free to interrupt us as we go. And we'll go ahead and get started. Awesome. So, Grant, next slide. Just before we dive into the meat of the training, want to give everyone a brief overview. I know I've recognizing quite a few familiar names and faces here. If you haven't had a chance to learn about California, Central California Rural REN, we are one of the newest regional energy networks. We were approved in September of 2024, and we lead 6 different programs, one of which is Codes and Standards. Next slide. A little bit about who we are. I am Jess Blackwell. I work with the High Sierra Energy Foundation, and we're based in the Eastern Sierra. We have partners in the Central Valley and San Joaquin Valley Clean Energy Organization, and on the coast with Association of Monterey Bay Area Governments. And then our program administrator is the County of San Luis Obispo, and County of Ventura serves an advisory role. Our 6 programs are shown here, and of course, you are all familiar with Codes and Standards, which is what brings us here today. And then I'm going to pass it over to our partners at Inbalance Green Consulting, Jennifer Rennick and Grant Murphy. Thank you so much.
Thanks, Jess. Hi, I'm Jennifer Rennick, and Grant Murphy works for us, is here as well. And one of the hats we wear is energy consultants, Title 24 work. I'm also a licensed architect, certified energy analyst, and Grant also is, how do you say it? Commissioning professional.
Oh, yeah, whatever the acronym for the commissioning. But CEA and the passive house certs, stuff like that.
Yes, and then so next slide. We also wear the hat of doing trainings like we're doing today, and we also are part of the Code Coach service that CCR REN has, and we also offer some specialty services, support for the standards. We helped work on some of the over-counter accessory dwelling units for some of the jurisdictions, et cetera. And jump to slide 7. Yeah, there we go. And with the Energy Code Coach, it's open to all of you. It's free. It's also open to project owners and builders, and a little bit of everybody's ratepayer money on their electric bill goes to the big, like PG&E, for example, if you're in that territory, and then PG&E would have that money for education and outreach. And in the past, a lot of that money went to really big, high population density areas and didn't make it out to the more rural or lower population areas. And so the RENs was created so that we would get our kind of fair share of that money and be able to do education and outreach that would be able to support the smaller jurisdictions. And as a code coach, we are available to answer your questions. So you can go to the Code Coach portal on the CCR REN website and reach out to us that way. And there's a pretty easy form to fill out, and usually Grant and sometimes me will get back to you in 1 to 2 days, and we'll also do a follow-up. Now, today with this roundtable, this is a little bit kind of an interesting format for us. I do have slides that I can go through, but really, we were kind of hoping, since almost everybody on the call is with one of the jurisdictions, we want to know what you're seeing, what questions you have, and if all else, we'll go through the slides. But there's like 80 of them, and we don't also want to just go over stuff you guys already know. But a lot of times when we start doing the education and outreach, just kind of the general public, They don't really understand how the energy code fits in context with California. So we can review that if you want. We'll probably skip that. What we also have found is that everyone is not familiar with water heater types, and so they don't really know what a heat pump water heater is or how it looks different from other tank type water heaters. So we could start with that as a real quick overview, and then Grant, that would be slide 15.
Yeah.
Um,
But we do want to just promote you guys punching in some questions. If you want to raise your hand or unmute and say what is causing oh, perfect. We already got research. We can talk research.
yes.
What's causing your pain points or confusion or even just your own testimonials of like, hey, we're battling this and this is how we handled it. We're hoping to go in many different directions today regarding water heaters. And then, like Jennifer said, we can key back to old stuff or just topics. So,
Right.
where do you want to go?
Yeah, so we could definitely talk about research pump and also when one of our other colleagues and I did a kind of a similar training down in for Santa Barbara County. One of the things that came up was just wanting to know where in the energy code were some of these new mandatory measures, because that way, if it came up now, the plans examiner, someone had that code reference. And so we could briefly do that. And then the other thing, what we're seeing a lot of is questions around that plumbing distribution and recirculation pumps and the different types, and also just some examples of what you might see in real life installations and sort of what to do about them. And some of that we can show examples of what we're seeing.
Well, James is already he's helping already. So he's got research, and then he's got they want to change out their HVAC system forms. So let's start with research. I'll just jump over to these slides, Jennifer, and we can talk
Yeah,
some research because this is one that comes up all the time. And we know it. I mean, I know in experience it gets ignored or swapped in field, or it's one of those. Where I start with research is I take private and public sector straight to this deep in the weeds of the code ACM manual. So this is actually the calculation when you're modeling distribution types. And we can all go over like, hey, here's on the forms, this is where you find the distribution type, what that means. But fundamentally, I, doing the Title 24 modeling work, have to explain to clients, architects, homeowners, that if they install a non-demand control recirculation pump, which is what a lot of people are accustomed to, and the built-in Navion ones are technically this non-demand control. That's a different, more in the weeds. But what happens is our budget for hot water is multiplied by 9.8 as a penalty. So a lot of single family residences, it makes it really hard to comply when you have recirc non-controlled. And the code, what it's doing, if you can see by these values they applied all these distributions, one would just be code. So anything less than one, you're getting credit. Anything over, penalty. So they want us to do a manual, this is a push button demand control at every fixture. This is a motion sense. I don't recommend those, but you can see there's still a penalty. It's just not as bad as a uncontrolled one. So James, your question was when is it required? Jennifer, I don't think in single family research is never required, right? Like energy code.
right.
It's always a owner-driven desire, and if you build a really wide house and you still have one unit that's not central, a lot of people want recirc so they don't have long lead times.
And then there is some confusion around the type of recirculation system where you basically go to the furthest sink of the house and you just um, have it set up so that there's a temperature sensor, there's a bypass with a temperature sensitive element on there. And it doesn't really fall into this kind of research category because what it does is you're allowed to turn on your cold water. You're allowed to turn on your water and just let it run until hot water finally gets there. And the thing is, then a lot of jurisdictions, they don't want that water to just run down the drain. So while it's still cold, before the water gets hot, so you've turned on your hot water, while that water is still cold, that temperature sensitive bypass sends that cold water back into the cold water recirculation loop, and eventually it's going to make its way to the tank. But that's okay because you already were pulling cold water from the city or from your well into your tank anyway. So this is just less cold water adding to it, and it doesn't waste water while the hot water makes its way to that fixture. And so we're seeing more of those, but those type don't really fall into these categories with those really big penalties because it's not causing your water to just recirculate um, willy-nilly or just recirculate because you press a button and then now it's causing all of your fixtures and on the water everywhere to recirculate.
Um,
But technically from our side of it, if they do put in those types of systems, then we're supposed to model it that way. We rarely see it. We rarely see it happen because a lot of times we don't even know if that gets installed or not. FYI.
yeah, I mean, one of my focuses for research in general is like when doing trainings and talking to plans examiners is identifying when something uh, is not included on the form, or because rarely you see compact plumbing credited and taken on a Tile 24 report without evidence in the plans. More often, you see evidence in the plans of a recirculation pump, and you don't see it included in the Title 24 report because they don't want to take that penalty. We also know that, after final, it's common people come in and put these things in. So there is an amount of oversight that we try to, push on to these designers to make sure this is actually accounted for.
Yeah, and you'll
Um,
notice a lot of the projects like this example right here. And mostly I put this example in because of all the insulation on the piping, and they did a good job of keeping the piping out of the wall until it needed to pass through the wall to get to another location. So a lot of the piping is insulated, which is good, but there is a recirculation pump on this. It is the demand type. Um, and you'll just see that's pretty common in a lot of the setups if you have a sprawling situation.
um, I'm pulling up a couple items to
Recording in
answer.
progress.
I know you guys can see this stuff jump up to answer James's other question about some forms. But please, James, chime in on what other research stuff you have. We can talk about their relevance to heat pump water heaters. Jennifer's done a lot of research working with people on how to properly pipe them and why it's not always such a good idea to put research with heat pump water heaters. Um, but we'd love your guys' feedback to where to go with
Oh
this.
yeah, and Jess, is it possible to unmute people or let
Yeah,
folks
absolutely. And I
just,
think I think Jim is unmuted and jumping in right here.
okay.
Well, in general, there's three types of recirculation systems that are basic to residences, depending if it's new construction or um, remodels to existing. You can do a return system where you go to the farthest fixture, pull a water line, hot water return line back from the farthest fixture back to the water heater and put a recirculating pump. There's on a retrofits, you can go and put a tiny little recirculating pump with a crossover from the hot water to the cold water on the farthest fixture in the house, and then a demand switch on the farthest fixture, or like the hallway at the farthest fixture in the house. And it'll take the water out of the hot water side, pump it back into the cold water side. And because of water balance, the water coming out of the tank allows the cold water to go back to the tank until the water reaches a predetermined 90 degrees, 95 degrees, coming up to that farthest fixture, which means most fixtures in the house are going to have hot water someplace close to them. And then once it reaches a temperature, the pump has sensor aquastat in it that turns the pump off. Um, some people will put it if it's a master suite, they're the first up in the morning, they'll hit that switch and it'll bring the water to the farthest fixture. Some people will put that button in the hallway, and so anybody in the hallway of the house could hit the switch and start the pump and get the water to maybe the second bathroom in the house that's close to that end of the house, or other locations. And then the third one would be the where you put that pump at the water heater itself, and a crossover at the farthest fixture in the house, that and a check valve on that will suck water from the cold water and pull it through the hot water into the farthest fixture of the house. And then when it goes all the way back to the pump, it'll turn the pump off. But so that you'll get warmer water in your cold water system for a longer period of time, more warm water in your cold water system for some part of the day.
Yeah.
Yeah, so Jennifer, what I'm getting, I mean, I'm familiar with a handful of these different distributions, especially in retrofits. The energy code doesn't really acknowledge the small single loop or different temperature set points and single push button. I want to say I was going to go over like here, Jennifer, maybe.
Hmm.
And I think James, you found you're not going to find a lot of information in the code book differentiating the different options and things we see in reality that you're talking about.
Yes. And I think the other thing to know, okay, with heat pump water heaters. So we got another question that came in, and it was just saying, hey, our water district gives credit for installing a recirculating pump or on-demand water heaters. So recirculating pumps do come up for us. So please, can you elaborate what the difficulties are of using them with heat pump water heaters? So there's a couple of things going on here. One, there's the discussion of, hey, are these recirculating systems being properly modeled in our Title 24? And if they are being modeled, they almost always result in a project that isn't passing Title 24. So to add a layer of requiring a HERS, or now ECC rater, to come out and look at it helps. Taking credit for all pipes being insulated helps. And then the type of systems that we were just talking about, there are some that don't sort of put too much of that hot water in your cold water pipes to begin with. So it's like, okay, we don't really have a good way of modeling that. And so a lot of times it just doesn't get modeled. Okay, put a pin in that. Then we've got the heat pump water heater technologies. And so a lot of the manufacturers now know that some type of, like, the crossover or the furthest fixture type of system is going to be often installed. And so they've tried to redesign the water inlet in such a way that your heat pump water heater is still going to work with recirculation. And for a while, a lot of the manufacturers were saying, don't put recirculating pumps on our appliance because it was dependent on stratification. And now there are some brands that if you know you're going to want to do some type of recirculation, then in getting that brand, you also could buy all the kits, the parts and pieces that go with that brand that allow you to do some recirculation. So the manufacturers are starting to address it. Then there's another piece that if you're looking at multifamily specifically, multifamily in our code says, hey, you need all your pipes insulated, but also there's just an installation, and I'm looking over for the slide. There is an installation on the heat pump water heaters that we do not recommend that we see in single family and explicitly under multifamily code. This in Title 24 Energy Code, this is not allowed. And that's where that return is actually plumbed into the tank cleanout at the bottom of the tank. So I think if you go to slide 64, slide 65, yes. Yes. So back up one slide.
Oh,
We'll
sorry.
start with that. Yeah. And so this is where we're saying, hey, do not put do not put your recirculation pump plumbed into the tank drain valve hose bib. That explicitly is not allowed in multifamily, but in the single family, they didn't get the language in there. And so we are seeing plumbers do this. And really, that that return, it should just be plumbed into the cold water inlet line. That's where it should go. And the reason for that is because at the bottom of the tank and how it's designed is the tank valve hose. It just ends right after the tank, but on the cold water inlet, it actually has some piping in there and some diffuser, and it helps allow the water to be at the bottom of the tank in a way that doesn't cause a lot of turbulence because heat pump water heaters, they do want a stratification. The heat pump water heaters often working and creating the hottest water at the top of the tank where it pulls your water, and it's trying to keep that inlet cold water uh, not creating turbulence, keep it at the bottom, and then let the tank stratify, and then allow, once the whole tank heats up, then it turns off the heat pump. So that would be one thing to look at. So multifamily, it's explicit. You have code language. Single family, we just see it and we don't recommend it. And the
Uh,
manufacturers say don't do it.
Jennifer, Jennifer, take a look at
Yeah.
what Dale just sent through. But while you're doing that, I wanted to go back to James. James, you mentioned all these different in-between research systems. You're a plans examiner at your counter. What is it that you're running into that is causing you, I don't know, confusion of allowing something or not, or you're hearing from contractors or designers saying we have to have research, or what is it that is really gumming up your reviews of plans
Well,
with
mine
your
was
with
more was is it does the energy codes or the Cal Green actually require that we see recirculating pumps in our residences?
So the short answer is no. No, the code does not require you to have research. It's an option that you can pick. So if you were reviewing a plan set that, let's say it's new construction and they show that they model the research in there, then that project should have research. But there's nowhere in the code that says certain size of home, distance to fixture. Hey, now it's mandatory that you install a research pump.
we see
right?
a lot of them because we're doing a lot of the, the Pebble Beach houses and things
Yeah.
like that, the mega mansions and the, you know, plans and things like that that uh, you would think would require them, but don't see them on there. And I've always
Yeah.
wondered in my head, is there something that says that it should actually be there?
So how it works is, I mean, it's going back to this little multiplier of options and talking about plumbing distribution design and like what good practices are. So when I work on maybe not the Pebble Beach mansions, but other mansions here on the Central Coast, you know, ranch style, super wide home design, wings of bedrooms and showers and baths, right? And that water heater is usually on one side of the home, or that's what they're trying to do. We don't design for it to be centrally located where you don't have the need for recirc. Well, then designer says we want recirc. And I tell them, oh boy, it's going to be hard to pass tile 24. And they say, no, we have to have it. And I say, okay, well, HVAC has to be more efficient, more wall insulation. Like we're starting to fight it from a different direction, but the code's not going to dictate, hey, you designed this very wide sweeping house that's inefficient. Therefore, you need to add recirc. They see that recirc as being inefficient, and so they penalize you for it. They then penalize you and give you guidebooks on this compact design, uh, parallel piping, that kind of stuff that give you credit. But that by the time it reaches your desk, that should already be incorporated in the plans. I hope that helped a little bit, kind of the whole process of how we view research getting into projects.
Yeah, and
Um,
then kind of related, um, Dale had that side question,
yeah, go ahead.
so did you see that, Grant?
Yeah, do you have a slide you want me to jump to?
Um, no, in this slide deck, I don't really have well, I mean, it's kind of related. This isn't really as big as you would see, but you could go to slide 60. I mean, some of the projects we're starting to see manifolds. This is a PEX manifold. Some people really don't recommend them because they're PEX. You can get metal manifolds, but part of what we are trying to get ahead of the curve for clients and the architects that we consult to is to use more point of use distribution and have more than one water heater in a project. And if we have a really big sprawling house, like we talked to them about using under sink electric at their wet bar because it's just right there. It's not regulated in the same way that the rest of your domestic hot water is being regulated. And just because this example shows an instantaneous water heater, um, it could be, you could also have a tank type water heater, it could be a heat pump. But the idea is also to educate people on how important it is to have the nominal size and the length of piping, but also a lot of the recirculation systems set up for the big houses, maybe it's like this question. They say you can walk the dog around the block before you get hot water to your kitchen sink. Is that sometimes the water pipe coming out of the water heater is a very large diameter. So you have an incredible amount of hot water. So what happens in the piping itself? And so what happens with the heat pump water heaters or any tank type for that matter that's really disappointing to people who have very large homes where the plumber used a very large diameter main loop is that you can empty almost your entire tank of hot water within the loop and then you finally get your hot water and then it doesn't last for very long. And so we do see very large houses sticking with gas tankless on demand, but what we try to do is get folks to do centralized, located centrally and or use more than one. Um, and really look at the size of the plumbing itself.
Yep.
And for really big houses, actually hire a plumbing engineer.
I mean, when I read Dale's question too, I mean, I start with 1,600 square feet, so we're not talking one of those really, really large homes that often are so sweeping and long distances. So I start with insulating the pipes. You know, can we get to them? How big of a retrofit is it to insulate the pipes? Code says you need to insulate hot and cold lines, new construction. There's some distance associated, Jennifer.
Yes, a single family, not so much, but if you want to get that credit, then you
Right,
can,
that's what it is.
insulate all the pipes. And then
So
multifamily says the first 5 feet of the cold pipe too. I
yeah,
mean, more than
starting there, identifying where the kitchen sink is on your loop, because you're right, maybe it's at the end of the loop, so you call for water and it's going to be the last fixture to receive the hot water, and that's why it takes so much longer. These are expensive retrofits generally. I mean, especially depending on where your hot water pipe is to insulate it, that can be a total pain. Um, the instantaneous units, like commonly the Navian, they have a built-in recirc pump. I mentioned that because it often just gets ignored in field by all participants in residential construction. It's supposed to learn your use schedule. That's how they advertise it. What has been shown to happen is that it learns that you use hot water all the time. So slowly after a month, it goes, hey, he uses it here, 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 and then second month goes by and it fills in a bunch of the blanks. And then you have a on-demand, uncontrolled research pump. Kind of a gray area item that not a lot of people are chasing, but it is part of this conversation. And we'll see it all the way to the other side where someone might be happy with their rate of hot water, but now their utility bill, they've seen an increase in electricity use and gas use. And depending on how much you pay for that, it can be enough to have you call us and say what happened. So, um, I don't know, Dale, chime in. Eric, chime in. Let us know if that was helpful or if we need to keep clarifying something there.
Yeah, my only question, if you can hear me there, can you hear me?
Yeah.
yes.
Um, is my house is a Lennar house, it's one of the nation's biggest builders, and that's what we see a lot in Manteca here. Is just this subdivision after subdivision, and they're all built that way. Now they have heat pump water heaters, and they're way down in the garage, 2 stories, and they get. And my thing is my wife and I get so disgusted with the amount of water that was being wasted, and
Yep.
every other house is doing that. And do we really have an energy problem in California? Oh, sure, but we're working on. Do we have a water problem? I think we probably have a water problem in California too, and I don't understand why they don't address this so much. That's my biggest thing is because there's so
Yeah.
much wasted water. And I didn't mean to get off in the weeds here. I really didn't. I was just wondering,
Oh,
you know.
that's entirely the point of this conversation, trying to just alleviate and share our opinions on this stuff. Jennifer, you're gonna have to, if you can, do a brief history because I always get mixed up because San Luis Obispo, where we're located, had a reach code targeting water, and at a certain point, the state overruled it because they did a study that showed that the energy waste was more significant than the water waste. And although that is a funded study and math and sampling and all that good stuff that's applicable to a statewide program. Uh, I hear your comment all the time, Dale. Like, hey, in reality, I'm watching a significant amount of water, and that looks to me like more of an issue than the minor electricity bill on my PG&E bill or whatever utility. Um, Jennifer, is there more background you can provide from when that changed? Because I feel like it did change by the state at one point.
Yeah. I'm trying to remember. I mean, there definitely is a water energy nexus. And the thing is, if like Dale saying, if we waste a lot of water, it turns out on the state level, we actually are wasting a lot of energy because it takes a lot of energy to get the water there. As so there is that nexus. It is being addressed a little more under the Cal Green Code, and we that's I wish I could go into it more, but right at the second I can't. I'm mostly like up on the energy code and like the better ways to install heat pump water heaters.
Well, I think that my
Absolutely.
biggest takeaway when thinking about that conversation is that uh, you know, having on-demand instantaneous gas, hot water available at any time, and or adding continuous recirc so it's available all the time, neither are the solution. The solution is, and neither is what Dale described, putting in a heat pump water heater and having a really, really poor distribution system where you're just wasting it. So it
None of
really
those are
comes
solutions.
right. It comes back to I think this plumbing distribution design is in the residential market and multifamily is really important, and maybe the code's not very concrete and easily enforced, but I think it's an important aspect of the energy code.
The
Right.
American
So
the American Society of Plumbing Engineers has done a lot of very, very deep studies into recirculating systems and on demand and sizing of water heaters and there's a lot of information out there, and they're more worried about the commercial world than they are the residential world. But you know,
interesting.
Yeah.
there is a lot of study that is taking place
Yep.
in the plumbing engineering world.
We need more good plumbing designers, maybe not engineers, so the res sector can afford them. I don't see a lot practicing. It's
Well,
definitely a need.
that was my background. I was 22 years as a plumbing designer back in the 80s and 90s.
Oh, come on back.
Oh, interesting. Yes, so it's totally near and dear to your heart, right? And so then like, I mean, because it's from one of the plumbing engineers that I know that really drove home to me what a big deal it was, your pipe being diameter for the quantity of water that's lost in the piping system itself, just pure volume, but then also the physics of it. And also what material the piping is made out of has a big impact. And then, like Grant said, it seems like getting it insulated properly. But I think my kind of takeaway on the architectural side of it is we try to get the architects to really think about the placement of their water heaters for the shortest runs and then at least go from there. Then they have a fighting chance of, you know, doing that.
Well,
Um,
the new PEX systems out there, and you'll see it in your diagram that you got up here right now. If your engineer is or designer is going right, then you buy the pre-insulated rolls where there's no joints in the insulation. There's no slitting to put the insulation on. There's no sliding insulation. When they buy the PEX pipe for the hot water pipe, they buy it with a half-inch molded foam insulation already installed. So when they're rolling it out and supporting it, it's you know that it's there's no voids in the insulation systems.
right. Like go to slide 58, Grant. So this is one I like to show too. Like, hey, if you're doing like just what you said, get the pre-insulated piping. And even if you're doing it correctly or well, then you want those pipe clamps to go over the insulation, which that other sh one didn't show. They stopped it to, attach the PEX piping. So like even for this one, it looks pretty good, but then there's room for improvement. And then what we're seeing is the only time this stuff gets picked up is if the energy consultant, the person producing the energy compliance forms, clicks the button that says, we want to take credit for all pipes insulated. Then if you have a good HERS or now ECC rater come out and they're supposed to do look at this, and if they're good, then they can help it also educate the
Yeah.
contractor too to tape those joints and to put the clamp around it and give them tips about buying the pre-insulated type of piping. But yeah,
Yeah,
I, I agree with
a
that.
good ECC rater, definitely a value add to the community to be helping guys with that. But like Jennifer said, it has to be selected in the report. We get pushback from just doing that because that means they then have to go hire the ECC rater. And if you hire a poor ECC rater, then what good do we really do? We just set money to someone not doing a good job. But then even our testimonials from our ECC rater, Paul Dunn, he does trainings on here all the time, is there's a wide range, of what he thinks is a good job because it's just the quality of work, it's very inconsistent. So even this, he's like, oh, that was a good job. Yeah, they missed a couple spots, but it's better than some things I've seen.
Right.
To that person that had the bathroom, the master bath far from the garage, go ahead and look at those under counter vanity recirculating systems that cross over from the hot to cold side. They're really a little miracle for problem solving for that situation.
Yes. Yeah. Yeah.
Tyson shot in that he's just the same, lamenting together. He's actually trying to, Tyson, you're up in Inyo. I think you wrote that in. Yeah, Inyo County. He's trying to require some kind of plumbing page, some P sheets for single family. I have a couple jurisdictions that are trying to do that down where I'm at. The same thing, design industry, residential architecture design is not used to paying for or having MNP sheets. We talk about like ACA-Calcs duct design, that's a gap already. Plumbing is in the same boat. I'll have to reach out to you because I'd be super curious what you're trying to ask for and what people are providing, if ever. Because it's something we're working with a couple of jurisdictions here on the Central Coast that um, trying to build consistency, so different architects or designers working across different counties kind of start to hear the same requests and what they want shown on these new res MMP sheets. Um,
Coming from the other side, I'd say watch out for that because most plumbing engineers are going to try to design the house like a commercial building, and then the plumbing
yeah.
contractor gets out there and looks at the general contractor and says, "Is that guy just out of his mind?" That's just we never do that and never seen that before.
Yeah, my
Yeah.
battle's been mostly with the mechanical design in single family res because it is codified. There is code pointing to you're supposed to have some type of document. And there's a lot of issues, just like you talked about, James, with the contractor saying, yeah, right, or poor mechanical ACA calcs done. Plumbing, I've been focused more on the uh, heat pump water heater ventilation requirements, space, correct position in a home, that kind of stuff. But you're right that the gap of as soon as you call an engineer and you have a project that can afford a mechanical engineer, oftentimes they're going to do commercial work because that's what they do for the majority of their day. I
Right.
don't see many residential engineers.
Grant, go to slide 70. This is at a bare minimum. We're kind of coaching the architects to start to do, and click the next button so that the other
Uh,
stuff shows
there
up.
more?
Yeah, because this stuff we're saying at least on the front page, call out. Now I say it's HERS measures, but it should say ECC measures now. Um, you know, just go ahead, and if the designer cares, to at least start to get all the pipes insulated. That's where we're trying to get them to do that. And then we're also trying to get them to really call out um, more plumbing notes. And the other thing we're seeing with heat pumps heat pump water heaters specifically is condensate drainage pathway be delineated. I don't know if that's come up for you guys, but we've had a few projects where the heat pump water heater, it's like the builder knows, hey, this has to go in, but folks don't realize that the heat pump water heaters have condensate. And then some of, even one of the plumbers who I thought locally that I was working with that I thought knew all this, we were just shooting the breeze on like how to run better piping and this and that. And then I mentioned, oh, and some folks don't even know that you have to deal with the condensate. And he's like, "Oh yeah, that's something that troubles me too because I'm never really sure where I should put it." And I said, "Well, you could run it outdoors. It's just condensed water." And he goes, "Oh, no, no, the code doesn't let me do that." And so there's this conflation of condensate that you would have on gas burning appliances, which the condensate is acidic. It's very different. But for heat pumps, the condensate both on space heating and water heating, it's literally just the moisture that was in the ambient air surrounding the appliance that is now condensed onto the evaporator coil, which is cold. And so you just don't want that water pooling up at the base of your appliance or inside your appliance. So there's a little line. If it's PEX, that's great. You can see if it's clogged up, but you can send that straight to the outdoors. Or if you go to slide, like there's example of it, you can do a floor drain like slide 42, Grant. And then you can even send it to like your, and if you go, you don't want to just send it to nowhere, which is kind of what we see in that image on the right. So in that case, they did have to figure out the solution and come back and fix it. That was a job site I went to. And then go to slide 35.
Your slides on there are improper, and those drains should actually terminate an inch above the top of the floor surface.
Correct. Yep, 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 that's
That's
right.
the plumbing engineer in me coming out. Sorry
Yep.
about that.
No,
And
don't be sorry. That's exactly it. A lot of times when like we did this for Santa Barbara, it's like at least they got the floor drain, but it's not supposed to go into the floor drain. And then slide 35, like you can send your discharge pipe to the outside, but you could send your condensate drain line, you give an air gap just like you do for your washer, but you could put it in that washing machine drain box. There's not a lot of condensate that comes off of them, depending on how humid the climate, how humid the air is around you, but it does need to
If
go somewhere.
properly done, you can take it to the tailpiece of your lavatories and your bathrooms also.
Right.
If it's done above between the sink outlet and the top of the weir of the trap, it has to be about an inch above the weir of the trap.
Yes, and I think in slide, yes, I have another picture where that was going to be the solution. It's somewhere in here. But yes, yeah, that's great. So I think the point for me too is a kind of a lot of folks don't realize that's what the condensate is. They don't realize that it's the same condensate you get on a cold glass of water. And so then as plans examiners, maybe ask for that. Do you like just ask them how they plan to deal with the condensate drainage pathways? But then it's also good for you all to know too when you're out there that if there is a lot of consternation about it, it's like it's only the moisture that's in the air that you're already breathing. So you don't have to worry about it being harmful or acidic or be part of, gas burning appliances.
I wanted to just return to this one because this is one that Jennifer's been kind of pushing out there to a lot of our design community, private sector asks. Like, hey, this is a way to improve your architectural sheets and try to build some kind of consistency. So at the end of the project, things don't go, hey, that was never on the plans. Uh, if any time any of you guys in planning, plan check or inspection are like, I'd love to have this note, or I ask for this note all the time because I know it works in my area. we love that kind of feedback, that insight. We kind of dump that into our trainings and talk about it. So anytime someone has comments or reviews, just email myself or Jennifer or reach out to the Code Coach line.
Oh,
So we can at least
yeah.
2 hours. I love it.
Okay.
What did
Two things,
Pam got
Grant.
something in?
Yeah, two comments came in, super important. Pam reminded me, yes, when you take the condensate line outdoors, you also see CERN has cold climates, right? So then it's not appropriate for your heat pump water heaters in the cold climates to be any place except inside the dwelling unit, because these things can't operate below well, they can't freeze. You don't want them to freeze. You want your pipes insulated. You want the interior closets. You want your pipes out of the outside walls. And then that condensate, you're either going to send it to one of the sinks above the P-trap or a floor drain that's part of all of your whole house's drainage systems where you're not going to get freezing and proper termination for that. Or, same like how you deal with your washing machine in cold climates. So you wouldn't just send it outdoors where the end of it could freeze.
And when we talk freezing climates, which is funny because it's also applicable to just places that have cold nights. Last I checked, when you dig deep into the spec sheets, many of these heat pump water heaters, when the intake ambient temp is below 40 degrees, a lot of them kick into electric resistance mode. And I know that number is hopefully coming down at some rate with new models coming out. But if it's below 40 for any certain duration of time, that unit is going to operate inefficiently. Yeah, we should be designing for these things to be inside conditioned space or have intakes where we can, control that intake temperature. So for Pam's climate where she's at, the way Jennifer said it, it's just they should be inside. You should not be designing for these things to be hanging out in snow climate.
Yeah, and really only on the coast and really mild climates, or should they be outdoors or acceptable? So that kind of full circle. I don't know what you guys are seeing, but in our milder climates, even a little bit inland, we're starting to see a lot of
One of these.
ADUs. Yeah, we're starting to see a lot of this, which we don't recommend. Um, we don't recommend that. And then on the Title 24 side, if you do go to slide 73, for example, um,
73. Oh, sorry.
yeah, 73, and you could click through it. I've highlighted a number of things, but this climate zone is mild enough in the sense that, hey, if it's really hot in the summer, you're going to get a greater efficiency on your heat pump water heater, and then the offset is in the winter. You're going to have more time where this appliance is going to run in electric resistance mode, like Grant was saying. But in this climate zone, there's no risk of pipes freezing. And then what we expect to see on the Title 24, and if this is something you're plan checking, is at the bottom table, and you go over to like column 6, Grant, you can put your arrow there. What we expect to see is tank location outside, duct inlet air outside, you know, duct outlet air. And it doesn't actually have to have a real duct on it, but it's where's the air coming from. And the source in this case is outside. The tank's outside, the source is outside, the air's going to outside, and we ran it performance mode. It still complies. They didn't get a credit on their water heater, but it passed, and then everything else was done. So that works. But in a
Yeah.
lot of climates, if you see any type of outdoor closet and the report doesn't say outside, 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 you do need to send it back. It may not pass. Or conversely, it might say garage, garage, garage. And if their garage doesn't have the possibility of freezing, that could be appropriate. Otherwise, for the colder climates, we expect to see tank location inside, air source inside, duct, you know, outlet
Yeah.
inside. And then for those, the solutions would be something like go to slide 76.
Yeah, I just wanted to note that this is a very fun new form printing thing that's not intuitive. So outside, outside, outside is the least amount of credit associated. As soon as you start saying inside or garage, the project is receiving credit for designating that air coming from and that tank location. So it's kind of that direction is where it becomes invalid. This is only
Right.
one.
And then, yeah. And so in this case, like the colder climates or, climates where just energy efficiency, it turns out that the heat pump water heaters, especially like in this scenario, you've got a heat pump water heater very close to your washing machine and to a sink. And then you could imagine that if you really were going to do some compact plumbing designs, you've got your kitchen nearby. And maybe it's a situation where it's designed such that the laundry washing area is off a pantry and then a larger kitchen for a larger house. The idea is that you could use a straight duct and send that air to a space that could benefit from a little bit cooler temperature and dehumidified air. So laundry space would be fine. A pantry would be fine. Even sometimes into people's kitchens would be fine. And then in this case, the kind of the makeup air in the sense of because we're sending air out the tank into another space, but we need water coming in, I mean, air coming into the heat pump, then like a fully louvered door or transfer grills would be fine. And because this system does not break the home pressure boundary itself, it, this is a perfectly good solution that you could start to see on plans as people become better aware of how to design with heat pump water heaters. Um,
I wanted to take a quick pause. I didn't realize that it's almost 3:30. That's
oh
when this
wow.
class is supposed to end. Um, well, I appreciate everyone's involvement. We can always, push for an extra minute or two if that's fine, if anyone's got quick comments. Uh, these roundtables, the idea, office hours, we've tried them a whole number of ways. They're a great idea. It just really relies on engagement with the audience, you guys attending and asking questions, throwing your own feedback and your own thoughts. We love, Pam or Jess would need to say what the next one is. I think there's more roundtables scheduled, maybe.
There
Do
is
you see that?
there
Someone
is
said,
another roundtable scheduled for, I believe that is our November course. And in the follow-up email for this, I will be sure to share a link to all the additional courses for this year. And I'm happy to keep things going if we want to keep the conversation going for a few extra minutes. I did just want to note that I think we had one question from, was it Araceli, who was asking about older homes and putting them in the basement. And
oh,
maybe
good.
we could speak to that.
Yes.
And then while that's happening, just in case anyone does need to jump off at 3:30, I just want to say a quick thank you to all of you for participating and joining us. I am also just going to run the poll while we're chatting. I think that it shouldn't interrupt anything, but if you guys could just share a little bit of feedback with us, it's helpful and an important part of our funding for providing these free courses. So I'll launch that now, but please feel free to answer Araceli's question.
Okay, so if you have a basement, and basements can be a good location, a really good location for heat pump water heaters, then depending on your situation, they do make very small pumps where for those kind of situations, I see it for like the heat pump water heaters, also for some of the HVAC equipment. And I don't think I included a picture in this slide deck for you this time, but they're very small pumps where you connect the condensate to it, the condensate drain line to it, and it has a small reservoir. And when that little reservoir reaches this point, then that little pump kicks on, and then you can send that water like up and over a doorway to get it to the sink if you need to, or where you do your washing, or a proper location for it. Um, Probably, depending on who else is still on the call, I was thinking our our former plumbing engineer can jump in potentially with the name
Yeah, I
with
don't think we have a
um,
slide of that in there, but that's good.
yeah, not this time. I did on another slide deck. I have a slide showing that situation.
If James is still here, I did see your question early on about the change out HVAC system forms. Uh, it's a topic for another day. Ping me on the code coach or on my email, and I can point you to where I send people to start, like the trigger sheets from Energy Code Ace, prescriptive alteration, and we can walk through some stuff. But it is something I find um, inconsistently enforced, and a lot of people have confusion for single
Well,
family
I
homes.
believe we used to do the CF3R, no, CF3R forms, but now I try to go in and pull the newest ones, and everything's locked up by with the not for use labeling and
Yeah,
stuff like that. We suggested that the contractors bring in the mechanical equipment form that just says that shows the listing and the ratings and listings on the equipment that it meets the California Title 24 requirements for sale in California, basically. And
yeah.
and
I help
you know,
I help a lot of people with using this form. This is the Alt '05 form with like all the scope to get something in there. I know that the real way now is using Cheers. You have online, create an account. That's difficult for a lot of people doing these swap outs. I found that it's really obstructive to having someone complete a form when you make them go make an online account first. So I use this one a lot for simple stuff. And then for on your side, this is 2025, and I think Energy Code Ace just came out with it. I refer a lot of people to Energy Code Ace's stuff. I know they like redo the code in here, which can be overwhelming and just more than we need. But this trigger table going through, this is single family, yes. There's a lot. Mandatory, prescriptive, distribution. So, anyways, that's something a topic for another day. But I just want to point out this is where I start to have that conversation, and feel free to reach out on Code Coach, and we can talk about it more.
Yeah, you know what? If we have a couple more minutes, probably the other thing that shows up all the time, well, two things just with the heat pump water heaters. One is the heat pump water heater doesn't have enough like air volume to really function properly. So just kind of keep in mind that the new mandatory measures spells that out. But what we've been telling the architects for just a rule of thumb or a guideline and this is based on the research done for the heat pump water heaters, like get them to start with 450 cubic feet of volume of a room. And if they have the space to do that. So like you could combine it with a utility room or laundry room. So that would be about like 7.5 feet by 8 feet by 8 feet tall, something like that. But a lot of folks don't have a room that size. So then get them to do a closet that's at least 3 feet by about 3.5 feet. And that way it's easy to install it. They have room for expansion tank if needed, and then do the fully louvered door with it. And then in certain climates, it would make sense. You could duct it to the outdoors. This is an example of a project, climate zone 5 or climate zone 3, where the it's mild enough and they just were able to duct the unit, the inlet and the outlet. You could You could do it in your attic if you wanted to. You could do it outdoors. It breaks the pressure boundary, so you seal penetrations and use an R6 duct, but it operates because for whatever reason, the homeowner didn't want any of the cool air blowing into the hallway where this unit was located. Um, and then the other thing that comes up is it's so minor, but a lot of people don't realize that there is a air filter on the air inlet. And so we just like to remind folks to think about that because sometimes the plumbing covers the air filter uh, ability place to pull it up, or sometimes the electrical contractor doesn't realize it. Like in this case, the plumbing engineer realized it, so it misses the filter, but then the conduit for the electrical was run short. So in this case, the electrician did come back out and lengthen it and arch it up, and then now the filter can get out. But those filters can be super easily cleaned. You can pop them in your dishwasher, or you can just vacuum them off or hose them off. Uh, but but they exist as part of it. So that's the other funky thing we're seeing. The homeowners can't do their regular maintenance. And then the units don't work so well. Some of them, like this A.O. Smith, the newer models are just pulling out horizontally, so it's a little easier to access.
Yeah, getting people to specify manufacturer, make, model, manufacturer seems to be getting more and more important earlier and earlier, which we know is difficult.
Right.
But
And then those metal closets, I mean, like, are they code compliant? Maybe. Maybe. I saw one recently that was in a bigger metal shed. Like this one, at least the manufacturer says, hey, you need 12 inches of clearance from the outlet port, which is that port on the right-hand side between an obstruction. And so this one's a little bit bigger closet. They meet that. It's still a funky closet outdoors. But the one thing it might not meet is how do you show if it's getting enough air circulation really to meet you probably the whole metal cabinet's probably super leaky. Plus, there's an upper louver and a lower louver, so they might meet that code requirement. I think if you go to the slide just previous, um, Grant, back up one.
that one,
Yeah, so the slide on the right, like it still has the upper and lower louvers on the door, and the whole cabinet's pretty leaky. But in this case, they actually got one with the louver on that right-hand side, and then the tank is angled so that it exhausts right at the louver, which is like how Ream recommends you do in their manual. So, and same with that funky little closet on the left-hand side. So again, if your Title 24 report says everything is outdoors, 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 maybe it works if they do everything else, but I don't know. I'm just curious if you guys are seeing this. We're seeing this go up where we're having a lot of housing pressures for ADUs. And so an ADU or a JADU is being built, and then they're bringing in these and picking up a cabinet from Lowe's or Home Depot and just trying to install it where they created an ADU in their existing house to give them a separate source of water.
We see it a lot.
You are too.
Yep.
Yeah, and then the slide after it, it's totally funky. Go to that one again. If you look at like, okay, so the hot water and cold water piping is coming out through a hole and then into what looks like they use for the hose bibs, and it's not insulated. Like there's some room for improvement, even though they did get the spacing. And then the condensate is just the horizontal piping to nowhere, which is going to drip and just and you can see that there's water at the base of the cabinet on the left. So I don't know if you guys are seeing this stuff, but we are. And technically, the ECC, HERS Rater we work with, who usually feeds me lots of these pictures, he's like, it's not on my forms. I try to educate people on it. I try and give them some improvement, but it really falls on the field inspectors from the jurisdiction. So that's why I was just wondering what you guys see and what you do. And maybe as an industry, we could get on the same page with some of this stuff.
We had a project here in County of Monterey where they did a stackable pre-manufactured housing apartment building, and they stuck heat pump water heaters in a conventional water heater closet with conventional water heater combustion air ductwork in it, and just blew the air right into the closet itself with just combustion air as the louvers. And the rooms sweated so bad they started molding. The room started molding within about a month or a month and a half after they
Oh,
and the mold was growing out from underneath the underneath the doors into the walkways, and the whole all the walls, the sheetrock in the walls were deteriorating within months of the installation.
right. And that's one of the biggest things too. The manufacturers often recommend 12 to 24 inches clearance from those exhaust ports, and citing that there's, this inner wall condensation then to mold, but we can't,
Well, it was a last
yeah,
minute changeover for energy efficiency that without any the thought as to, oh, hey, it's a great idea, let's change water heaters from just standard electric water heaters to heat pump water heaters. It's a great idea, let's do it, let's do it, let's do it. And nobody even understood the or looked into the ramifications, and until it was too
Yeah,
right.
late.
I mean, in the follow through, I remember when these first things came online, the code and manufacturers, I would tell people, yeah, minimum 750 cubic feet of volume in the room, or maybe 1,000. And now manufacturers are what, 400 to 450, they'll have on their installation instructions. Like it's
Yeah,
already been
around there.
halved.
And then the code, the mandatory measure, if you do like the capacity of the heat pump
Yeah.
times 100 cubic feet. So like with the reams, most of those are about 4.2 K BTU. So you end up with the 420 cubic feet. But we say, okay, architects, rule of thumb, do the 450 at the minimum. And then a lot of the studies where they minimize that room size, 1,700 bigger, beautiful. 1,000 to 700, you're still reaching that potential. You drop it down to the 450, and then you've lost about 8% efficiency. So that's where the manufacturers are saying, yeah, you could go smaller, because they're thinking that's an acceptable amount of efficiency loss to still get their product sold. And then,
I mean,
yeah.
even when I was saying that large of a space, we were still seeing it put in closets, just retrofit closets. You know, people didn't care. They didn't, even though we were trying to say like straight from the manufacturer, they do not encourage this install unless you have a large space. And
Right?
then the proximity of that exhaust port, I know Gary's doing a bunch of research on it, where depending on the position, oh, it's not that bad, dew point on that wall assembly, but then he goes, hey, what if it's an exterior wall? What if it's not 12 inches away and it's 4 inches away? And he shows us one where it's literally sitting on the wall. So there's a lot of work to still be done in the details, but these are getting thrown all over the state. So anyway,
Is ducting in and out of an attic a good idea?
That can be fine. It really can be, because and there was some research showing that, hey, that cool dehumidified air going up into your attic can be great. That could be great. And so it drops the temperature in large spaces, and your attic's potentially large. It only drops the temperature by a few degrees typically, But if in the summertime, if it's pulling warm air from your attic to heat your hot water, and then you're sending it back to your attic at a different part, plus your attic is a ventilated attic, that combination seems to work fine. It's the now you're going to do an R6 duct and air and do the sealing, sealing, sealing around it because it's theoretically broken your air barrier boundary of the house. Um, so yeah, so that can work. And then for the cold, really cold climates, um, then just having everything to the interior is the way to do it because a lot of the cold climates aren't going to have ventilated attics anyway. And those
I
are
think it
kind of
looked
those are the main things we're seeing right now on these integrated heat pump. And for really cold climates too, it might just be appropriate to go to split system heat pump water heaters.
which we can talk about another time. I'm gonna pull the plug on you,
Yep.
Jennifer. We stole an extra almost 20 minutes. Appreciate everyone for participating. Code Coach, reach us this way. Here's the form. It'll reach me and Jennifer. Happy to talk about this stuff anytime. And look for the future events.
Thanks, you guys.
Thanks,
Thank
everyone.
you. Thanks for participating.
Yeah, thank you all. Really appreciate you. And look out for an email from me with all the course materials. So.